here we are in section 4, the last section before your quiz. We're finding an equation of a line. Now, so far in these sections, we've looked at standard form, ax plus by equals c. Last section, we looked sort of informally at slope-intercept form, y equals mx plus b, and we also looked at how these two equations are related. Now, we're going to remind ourselves and look at this point slope form where I'm looking at x values, y values, and the slope at the same time. So follow along with me on page 118 in your book. What I need to mention is every single one of these equations represents the same thing. There are three different forms, three different ways at looking at the same concept. The reason that we have these three different forms is that in any given situation, it might be most easy to understand a line like this. Perhaps, given different information, this is the most easy way to understand the equation of a line. In a different situation, perhaps this would be the easiest way to understand the equation of the line. So let's be clear. Each of these represent the exact same thing, and we'll look at that. They're just three different ways of expressing the same idea. Okay, let's consider for a second that we have this formula for slope. Okay, m equals the change in y over the change in x. Now, what if I were to say move the denominator over to the other side? So that is to say, I'm going to multiply both sides by this denominator, right? Multiply both sides by the denominator. And what that essentially is going to do is move the denominator up here. This is going to go away. I'm going to have this in parentheses here. Now, if you look closely, this looks awfully similar to what we were just looking at in point slope form. Point slope form being y minus y1 equals slope times x minus x1. That's pretty cool. So if I just rearrange my slope formula, then I get this form of a line called point slope form. The purpose of showing you some of these connections is if you can just remember one of these forms and then remember how they're related to each other, rather than memorizing 5 different formulas for this quiz, you could just remember 1 or 2 and then remember how they're related and derive the other ones as you need them. Now I'm looking at example 2 on page 118. It says, given these 2 points, I want to find the standard form of the linear function. When I'm given 2 points, all I can really do is start by finding slope. So I'm going to just label for myself that I've got x1, y1, x2, y2, and then use that information to fill in for my slope formula. So y2 is 1 minus a negative 2 over 5 minus 1. Simplifying, I've got 1 plus 2 over 4, which is 3 over 4. So I've got this slope that is 3 over 4. Now I'm going to choose one of my various line formulas to work with. Typically when I'm given a point, I can use point slope form in order to figure out the equation for my line. So I'm going to choose either one of these points. It really doesn't matter which one that I choose. Typically, I'm going to go with the one that I feel most comfortable working with the numbers inside. These numbers are a little bit easier for me to work with in my head, even though I've got that negative. So I'm going to choose this point. You could easily choose that point and we would get the same answer. Okay? So now I'm going to think about this point-slope form. I'm going to remember that it's very similar to the slope formula that I used here, y2 over y1 over x2 minus x1, right? But instead, I'm going to make it, I'm going to use the y's, y minus y1 equals slope times x minus x1, right? So just rearranging that slope formula. Now I'm going to plug in what I know. I'm going to leave this y that's not labeled with a subnumber as just y. Same with the x here. Okay. Then I'm going to plug in my slope. I know it's 3/4. And then I'm going to use the point, the values that match within this coordinate point. So the y value then is -2, so I'm going to say minus a -2. And then I have over here -1. So plugged in a -2 here, plugged in a 1 right there. Now I'm just going to use my best simplification skills to clean this formula up just a little bit. So applying a little distribution, combining of signs, I get y plus 2 equals 3/4 x minus 3/4. Now I've got to change this formula into standard form. To do that, I'm going to shrink everything, make it a little bit smaller so that we have some more room to write. Okay, so made things smaller, and then I just moved the next step after this one, I moved it to right here. So I'm reading down and then over. Now, in order to have standard form, I'll remember from standard form, why don't we just write it back up here? I've got ax plus b, y equals c. I notice from these, I don't have fractions. I don't really want to have fractions in the final answer. What's nice about this equation here is it will be pretty easy to clear these fractions. All I need to do is multiply by 4. Now, if you're not quite seeing that, I'm going to rewrite this part, this side of the equation, as one fraction. You'll notice they already have a common denominator, so I'm just going to put it all over 1. So watch as I do that. I've got y plus 2, and then I'm going to say 3x minus 3 all over 4. So now this is going to look a little bit easier for clearing that fraction. I'm going to multiply by 4 on both sides in order to cancel, multiplying the whole side by 4 over here. So these two cancel. And then I'm going to use a little bit of distribution there. So I'm going to have 4y plus 8 equals 3x minus 3. Okay. Now, I'm still not quite to this form where I've got coefficient then x, coefficient then y, and then c. So why don't I move this x term over here, this constant term over there. So I've got this equation here, negative 3x plus 4y equals negative 11. It looks so close to this, but one of the stipulations we haven't talked about yet is that I always want, whenever I have something in standard form, I always want the first term to be positive. It's just convention, it's just the tradition that we use, but as we move forward, it's going to be important to remember to have this a value be positive. So in order to do that, I'm going to multiply this entire thing by -1. Okay? Excuse me. So I'm multiplying by -1 on both sides, keeping everything balanced. It's not changing a value, it's just changing the signs around. So my final answer is going to be 3x minus 4y equals positive 11. Okay? So let's just go back to the beginning and make sure that we've answered the question. They gave us 2 points. They asked us to find standard form. So when I'm given 2 points, I know I can find a slope. So I'm not sure exactly where I'm going at, but I know with 2 points I can find a slope, so I do. Now, I've got two different types of formulas that deal with slope. Standard form isn't one of them, unfortunately. So I've got point-slope form, and I've got slope-intercept form. I haven't talked about an intercept anywhere, so I'm going to use point-slope form. I've got a point and a slope, so I'm using point-slope form here. Plug in what I know. I've got slope, and then I chose this point, so I plugged in -2 and a 1, simplified, and I got this equation. This equation doesn't quite match what I want here, so my first move was to clear the fractions in the denominator. Clear the fraction in the denominator, and I got this form, which again is looking similar to that, but not quite enough. I want x's to be on the left, y to be on the left, and then constants to be on the right. So I moved everything around, got this, had a negative in front of the a. I want it to be a positive a term. So I multiplied everything by -1, and I found the standard form of the equation that runs through these 2 points. Okay, the last little concept that I want to go over is the idea of parallel versus perpendicular slopes. So we'll remember that parallel lines are lines that never intersect. Parallel lines are lines that never intersect. It's worth writing down. Perpendicular are lines that intersect specifically at a 90-degree angle. You'll remember from geometry, specifically at a 90-degree angle. Now, what we can do then is we can find equations for slope find equations for a line knowing or being given a particular slope. So if I have a slope that is -5, any line parallel to this given slope is going to have the same slope. So parallel is going to mean same slope, which means that a parallel line is going to have a slope of -5. Okay? Now perpendicular slope, I've got to change it somehow, but it's got to be very particular because I want these two lines to intersect specifically at a 90-degree angle. So this is where I'm going to look at, the negative reciprocal, okay? So I'm going to look at the slope of, well, let's just write that out for a second. We've got the negative reciprocal. So if I'm looking at the original line having a slope of -5, then the slope of the negative reciprocal is going to be negative, right? And then I'm going to take the reciprocal of this -5. So I'm just going to remember that any number can be over 1. So the reciprocal of this is going to be 1 over 5. And it was negative. So now I'm just going to simplify this term. Flipped the fraction upside down, and then negated the negative. So my slope for a perpendicular line is going to be a positive 1/5. Now, given all of this information, you should be able to get through the exercises that start on page 121. Again, starting with the written exercises. Please bring your questions to class. Also, I encourage you, I didn't go over every single example. I do encourage you to read through and make sure that the examples in this section are making sense to you.